Liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe. NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, and more beautiful than humanity's dreams. High above our planet, a sentinel of science has been silently orbiting, peering into the abyss of time and space. The James Webb Space Telescope, a marvel of human ingenuity, has just made a series of discoveries that will send shivers down your spine. Scientists and astronomers from around the world have been working tirelessly, poring over the data beamed back from this cutting-edge telescope. Each piece of this remarkable instrument we put in space is finding things that we didn't expect, that we can't explain, because that means we have to revise our understanding of the universe. What they found at the edge of the universe is nothing short of astonishing. As we gaze into the cosmic abyss, embark on a mission of cosmic proportions, where James Webb's astonishing discoveries reveal the untold secrets lurking at the very edge of the universe. The cosmic time machine, the James Webb Space Telescope, is an incredible accomplishment in the world of space telescopes. It's specially made for studying infrared light from space, allowing it to see far into the universe and discover objects that are very dim, very old, and very far away. According to information provided by NASA, the JWST exhibits remarkable sensitivity to infrared radiation to the extent that it can discern even the faint thermal emissions emanating from a bumblebee even when positioned at a lunar distance. To provide a more quantitative perspective, this astronomical instrument boasts a performance level exceeding that of the renowned Hubble Space Telescope by a factor of 100, an instrument that has admirably contributed to our understanding of the cosmos for over 3 decades. The primary objective of the JWST is to capture celestial imagery during the early stages of the universe's formation. While the Hubble telescope has delivered awe-inspiring images of the cosmos, it does possess inherent. This law posits that objects observed in deep space exhibit a phenomenon known as redshift, wherein the wavelength of light shifts towards the longer red end of the electromagnetic spectrum. But what prompts this wavelength elongation? One fundamental factor is the expansion of space itself. It is crucial to note that this expansion extends beyond mere object separation, it encompasses the very fabric of space. The intriguing aspect of this phenomenon is its acceleration, attributed in part to the influential presence of dark matter and dark energy. Consequently, when calculating the universe's dimensions, we must factor in the additional distance resulting from the expansion of space. Consequently, the boundary of the universe is not confined to a mere 13 billion light-years from Earth, but is extrapolated to extend far beyond this point. Chasing light beyond infinity, one notable phenomenon within the universe is the existence of objects that may forever remain beyond our visual perception. Why is this the case? The answer lies in a staggering distance of approximately 16 billion light-years from Earth, which marks the current cosmic event horizon of our universe. At present, we have not yet reached this threshold. This distance serves as the utmost boundary for light to reach us if it were to originate from that distant point today. Consequently, this implies that beyond the 16 billion light-year mark, the expansion of space outpaces the speed. This intricate sun shield was folded up during the telescope's launch on Christmas. Remarkably, in less than 2 weeks, the sun shield's incredibly thin layers were successfully unfurled. This sun shield plays a vital role in safeguarding the telescope from the intense heat emanating from the sun, which would otherwise inundate its sensitive sensors. The side of the telescope that faces the sun must endure temperatures of approximately 260 degrees Fahrenheit, while the opposite side is cooled to an astonishingly frigid 370 degrees below zero. This results in an almost staggering temperature difference of nearly 600 degrees between the two sides. This sun shield bestows upon the Webb telescope an astonishing level of sun protection comparable to an SPF of 1 million. A million miles from help, one shot at perfection. One aspect that causes concern among scientists regarding the Webb telescope is its inability to address any problems that may arise both during its launch and while in operation. To provide some perspective, throughout Hubble's existence, 5 space shuttle missions were conducted to correct its initially blurred vision and to perform various maintenance and upgrades. However, this was feasible because Hubble is a mere 340 miles away from Earth. In stark contrast, the Webb telescope is situated significantly farther, nearly a million miles distant, placing it well beyond the reach of repair crews conducting spacewalks. Therefore, NASA has just one opportunity to ensure its flawless performance. Nonetheless, if the necessary technology is developed, scientists might eventually dispatch a robot to refuel the Webb telescope, thereby extending its operational lifespan. Regarding its fuel supply, initially, NASA estimated that the telescope would only remain functional for a decade. However, due to an efficient launch, there is presently sufficient fuel remaining to power the JWST for a total of 20 years. It's fascinating to note that the James Webb Space Telescope has already demonstrated its value despite its nearly $10 billion cost even before capturing its initial images. Northrop Grumman, the company responsible for constructing the telescope's mirrors, had to pioneer entirely new methods since creating such a precise mirror had never been attempted before. The innovative technology they devised is now even being applied by eye surgeons. In addition, Northrop Grumman made significant strides in the realm of computer technology. They achieved remarkable progress in understanding how to efficiently deploy massive objects. For instance, they mastered the art of taking a colossal sun shield equivalent in size to a tennis court and folding it up neatly for deployment. James Webb Telescope's terrifying discovery at the edge of the universe, human curiosity has always revolved around the mysteries of our surroundings, yet voyaging across the universe entails not only traversing vast distances in space but also navigating the depths of time itself. Before we embark on this cosmic journey, it's essential to establish a fundamental parameter: the universe's dimensions. To pinpoint its edge, we must first grasp the sheer scope of the universe. Our universe is believed to be a venerable 13.772 billion years old, indicating its considerable age. So, just how expansive is our universe? Present-day scientists estimate its width to be 28.5 billion parsecs. To comprehend the enormity of this figure, we need to delve into some astronomical basics. To begin, let's consider the size of a parsec. To grasp the definition of a parsec, we should first acquaint ourselves with the concept of an astronomical unit, often abbreviated as AU. 1 AU represents the average distance between the Sun and Earth, approximately 150 million kilometers. Now, a parsec is defined as the longest side of a triangle with its shortest side measuring 1 AU while subtending an angle of 1 arcsecond at the opposite vertex.